Hey guys, it's Miss Anderson. Welcome back from spring break. I hope everybody enjoyed their time quarantining inside. We are back for week 4, day 1. I am here for all 3rd grade math, okay? So whether your teacher is Miss Levine, Miss E, or Miss Anderson, you are in the right spot for math. All right, before we get started, I want to go over just a few things. First and foremost, we are starting with lesson 22, liquid volume. We are also going to slow things down just a little bit. And you can see we're only going to do the first 5 pages today. That's all you have to do today. Pages 230 to 235. We're not going to go past that, okay? Our objective for today says that I can measure and estimate liquid volumes and masses of objects using standard units. So we're going to go into that. We're going to talk about measuring and estimating how much liquid we have in something. Our vocabulary that we are going to be looking at or using today is measure, estimate, liquid, volume, and liters. And sometimes you just see it represented with an L. So let's take a look over here. All right, it says in lesson 2021, you learned about measuring time using minutes and hours. You did. You can also measure liquid volume. Take a look at this problem. Zeke has a small bucket and a large bucket. That's right here. He wants to know how much water each of the 2 buckets can hold. He has a ruler and a measuring cup. How can Zeke measure the amounts of water each bucket can hold? So let's look. It says, think about measuring how tall each bucket is. Explain how you would do this. So if we think about it, this is A. If I wanted to measure how tall something is, which one of these measurement tools would better help me? Would it be the ruler or the measuring cup? If you said ruler, you are correct. So to explain this, I could simply say, I would use the ruler to measure how tall the buckets are. I would start at the bottom of the bucket and measure to the top of the bucket. All right, if you need to, pause the video to give yourself some time to write your sentence. All right, B, does measuring how tall each bucket is help you know how much water each bucket can hold? Explain why or why not. So I want us to think about this. If you take your ruler and you measure how tall the bucket is, does that actually tell you how much water you're going to be able to put in your bucket? So if the bucket is maybe 3 inches tall, does that tell you how many cups of water you may put in your bucket? If you said no, you are correct. So for our answer, we're going to put no, because the length of a bucket does not tell how much water is needed. Say 2 buckets can have 2 different lengths, but hold the same amount of water. All right, good job, guys. Again, pause if you need to take some time to write. All right, C. What tool can Zeke use to measure the amount of water each bucket can hold? So again, we have our ruler and our measuring cup. Which one of these would we use to measure how much or the total amount of water is being poured into the bucket? The measuring cup, good job. So simply put, the measuring cup. Let's fix that. And again, guys, just pause in between each question to give yourself time to write. D, explain how Zeke can measure the amount of water each bucket can hold. So if we're looking here, you can see our measuring cup is a lot smaller than our buckets. So what he can do is Zeke can keep track of the amount of times he fills he fills the measuring cup up and pours it into the bucket until it is filled. So what I mean by that is, let's say this measuring cup holds 2 cups of water, okay? He fills it up, 2 cups, and he pours it into the blue bucket. Okay, that's 2 cups. Then it's not filled yet. So now he's got to fill it up again. That's another 2 cups, and he pours it into the blue cup. Now there are 4 cups in the blue bucket. Let's say he fills it up one more time. All right, and he pours it in, and now it's filled up. So that was 3 times he had to fill up his cup, or his 2 cups. So if we count, it's 2, 4, 6, which means it was 6 cups that filled it up. That's just an example. Let's move on. All right, let's do some reading. It says, when you measure how much water is in a bucket, you measure liquid volume. So again, when we're talking about how much water you put into these buckets, we call that liquid volume, okay? To measure the amount of water in each bucket, Zeke must use something that holds liquid like the measuring cup. He can count how many times he fills the measuring cup and pours it into each bucket until the bucket is full. And that's what we said. The total number of measuring cups describes the liquid volume of each bucket. There are standard units for measuring liquid volume. A liter, that's another one of our vocabulary words we talked about, is a standard unit of liquid volume. So when we're talking about measuring liquid, sometimes you might measure it in liters. You can measure the number of liters in a container by using a measuring cup or a liter beaker. This is another tool that holds liquid. A picture can help you understand about how much liquid 1 liter is. Each of the 3 pictures below shows about 1 liter of liquid. So if we look here, you've got this bottle of water, that's 1 liter. 4 cartons of milk, if we were to pour them all into one container, it would be a liter of milk. And we have a gallon of milk, but this little bit that's down here, if you look closely, this 1/4 of the gallon, or 1/4 of the milk carton, is 1 liter. So now let's reflect. It says, name 1 container that definitely holds less than 1 liter, 1 container that holds about 1 liter, and 1 container that definitely holds more than 1 liter. So what we can do is actually use these pictures up here to help us. So name 1 container that definitely holds less than 1 liter. So if you look, our 4 milk cartons equals 1 liter. So that means if I only had 1 milk carton, that would be less than 1 liter. So we can put a small carton of milk holds less than 1 liter. And then our next part says 1 container that holds about 1 liter. We know this bottle of water is 1 liter, and it says a large bottle of water. So a large bottle of water holds 1 liter. All right, and then lastly, in 1 container that definitely holds more than 1 liter. So if we look at our carton of milk, our gallon of milk, the whole thing does not equal 1 liter, only if we filled it up 1/4 of the way. If this whole thing was filled up, it would be 1 gallon, which is more than a liter. So 1 gallon of milk holds more than 1 liter. Okay, and remember, you may pause to write all of this down if you need to. All right, we are almost done, guys. Good job. All right, estimating liquid volumes. Now we're going to talk about estimation. Remember, estimating is making an educated guess. We want to get as close as possible. Think about rounding. That's another form of estimating. All right, Kayla will use a liter carton to fill her goldfish's small fish tank. Estimate how many liters of water the fish tank can hold. So this is 1 liter and she wants to fill this whole thing up. All right, you can use a model to help you estimate. You can picture how many liter cartons would fit inside the fish tank. So if you look, if she kept putting the cartons in the fish tank, it would take 1 liter, 2 liters, 3 liters, 4 liters, 5 liters, 6 liters, 7 liters, 8 liters. So we know that this would be 8 liters. All right, you can also model it. You can model the problem in another way to help you estimate. This shows 1 liter of water in the fish tank. You could think about what fraction of the fish tank is filled with when it has 1 liter of water in it. So you could kind of like estimate and think like, what fraction of this is the fish tank filled up? All right, now we're going to estimate to solve the problem from the previous page about the fish tank. So let me get started. Number 2 says, look at the 1 liter of water shown in the fish tank and model it. Explain how to find the fraction of the fish tank that is filled with water. Okay, so if we go back to here, so if we're looking here, you can see the part that they filled. This is the 1 liter. So what we could actually do is, if we wanted to figure out what fraction of this has already been filled, we could kind of mark this piece and then estimate about, if we filled it up the same amount each time, how many times that would be. So to put that in better words, say you can mark the fish tank with the same amount of water that was filled on the bottom until you reach the top of the tank, period. So again, what I mean by that is, if I was to mark here and then kind of estimate, okay, it's about this much, so maybe I come about here, okay, that's 2, and then maybe a little more, 3, 4, 5, 6, 7, 8, and then I know there'd be 8 equal pieces, or 8 equal parts. So if there's 8 equal parts, then that means it would be 1/8 is filled in at the bottom. So now number 3, it says, explain how you can use this fraction to estimate how many liters of water the fish tank holds, which is what we just said. So if the bottom, we'll say the bottom, or we'll say nope. If the first liter is 1/8 of the tank, then I know that it will take 8 liters to fill in the fish tank. Because again, if this piece here, if it takes 8 equal parts or 8 liters to fill it up, this is 1 of those 8 liters. So 1 out of the 8 liters is already on the bottom, and if I keep going, it'll be 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s, and then 8 8s, which is 1 whole. Please join me in part 2.